Hello and welcome to this video on milk. Milk is perhaps the most common dairy product. It is available from many animals, the most common generally being cows, sheep and goats. While there is some variation to the exact contents in milk by species, there is a general similarity to the contents. You have lipids or fat, the proteins, of which the majority is casein, minerals like calcium, phosphate and magnesium. Finally, there are sugars like lactose. These four categories are present in all milk and, to a certain extent, all milk products. There is some variation between species, but you'll always find that these four things are present along with a considerable amount of water. Water by far and away makes up the majority, somewhere verging on 70 to 80%, or in that range. Then you have lipids. These are the next largest present item, although not always exactly the leading item. Generally speaking, if talking about skim milk, full cream milk, light milk, and so on. But they are still the majority. Lipids are the generic term for fat, and the fat is mostly made up of triacylglycerols. These are long chains. In fact, it's 3 long chains of glycerol molecules that are bound together with a small joiner molecule at the end. When your body uses this, it is able to break off each of these chains, or the far end of them, and shorten them gradually, and this allows you to use the available energy without having to break down the entire molecule. It's the same thing that your body uses in the liver for storing energy over the short term in the form of glycerol. The important thing with this is that they're not just present in that form. They're present in small globules. These small globules are surrounded by a membrane, and that needs to be there because you can't mix lipids and water. It's the simple reality that oil and water don't mix, and you'll see this anytime you try and do that. By surrounding it with a membrane, you're able to fundamentally have an emulsifier effect. That allows for the lipids to mix readily with the mostly water of milk. The other important element to this is that the membrane prevents the lipids from coming together and separating from the milk. And that's why you get full cream milk or similar, and you can, if you're so inclined to do, separate out the cream from the milk itself. You'll also find that there are some other lipids present, mostly short links of glycerols, for example mono and diglycerols, along with some cholesterol. Other than lipids, you find the next major element in milk is going to be protein, and the vast majority, generally 80% or more, is casein. Casein is what you are focusing on when you use rennet to make cheese and similar. Casein is interesting largely because it's resistant to most treatments except for enzymes that specifically target it. And that's because most proteases can break down casein, but it's also water soluble, so it doesn't really separate itself out from the rest of the milk. This means you don't need to worry about it aggregating and creating clumps unless your milk goes bad. The other possibility is when you use rennet to break down the casein and allow it to re-aggregate and create curds for cheese making. The other one is lactoglobulins, and these are part of the protein structures used in milk, largely again to try and hold on to various structures. They are basically just proteins within milk. You normally find that casein makes up more than 80% of the protein in milk, and then you have whey proteins, which are things like the lactoglobulin, make up about 20%, although this can vary wildly between species, where, for instance, casein makes up about 30% in humans, but the whey proteins make up about 70%. We also need to talk about the variety of minerals within milk. These are what people often think of first. The idea that milk makes for strong bones. And to a certain extent, this is true. Some of the most prevalent minerals in milk are things like calcium, phosphate, magnesium, and similar. All of these are essential for bone development, but they're also a cation and anions. That is, they have a small positive charge or a small negative charge, and that's what their role is within bones. They provide part of that mineralization. By itself, it's really just a convenient storage mechanism, largely because the minerals within it generally are able to be kept in the milk and help to stabilize the entirety of its contents. Thinking particularly of things like casein here, where by combining it with a mineral or cation or anion, you're able to have it set up a sort of matrix or a crystalline structure. Not a very strong one, but enough that it is stable. Because you have both the proteins, lipids, and these minerals, you'll find that you can saturate the milk with a lot more of the minerals than you should normally be able to. And that's because the solubility of things like calcium is much greater in the environment full of things like protein. Not so much because it dissolves in the milk, but because it gets caught in the mesh of all the proteins. There are other, let's say, additional benefits inside of milk, and these are things like vitamins. Although, largely speaking, they're not a very significant part of it, they are all present. B vitamins, C vitamin, D vitamin, K vitamin, E vitamin, and a number of others. Finally, we have the carbohydrates or sugars within milk. The most prevalent is going to be lactose, and for those who have lactose intolerance, this is what you're trying to avoid. There is a much smaller and comparatively insignificant amount of glucose, galactose, and shorter lengths of saccharides. Lactose is primarily what you would be aware of with milk, and it's why it tastes sweet. It makes up about 40% of the sugars within milk. The lactose itself is made up of the glucose and galactose, which are the primary other sugars within your milk. It's also what's being used for various fermented products in a lot of cases. For example, lactose gets turned into lactic acid in the case of yogurt. It's also used to create, ethanol to a certain extent, for certain fermented milk beverages. Of course, you won't find lactose in lactose-free milk, so that's a consideration. There are also certain, let's say, milk types that have been made that specifically minimize the amount of it present. For example, skim milk tends to have less. That is simply because you are taking out the saccharides or sugars in skim milk to make it, skim. You also remove a great deal of the lipids as well for the same purpose. This is what makes up milk. The many parts are what make it very nutritious, but also very useful for cheese, yogurt, and more dairy products. Depending on which of these you have more or less of, you can make a great many different products. Notably different kinds of cheeses, but there are also other benefits. Thank you for watching this video. If you found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you have below.